Okay, yes, we're good to go. Okay, this is the second section, parabolas. Okay, really quick, just give you a heads up. Now, have that formula sheet ready. You're going to either use this one, x minus h squared equals 4p times y minus k. Hang on one second, let me get rid of this. Okay, that formula is only used when the parabola goes up or down. Okay, next you will either, the other formula would be y minus k squared and 4p times x minus h. Okay, use this formula when the parabola goes right and left. Okay, remember the p-value? The p-value is going to be from vertex to the focus. In this case, it would be negative. In this case, it would be positive. Here it would be negative. Here it would be positive p. Okay? All right, just a quick, that was a quick review. Ready? Number 9. Number 9. I will sketch a lot of this, so I hope you do on the quiz tomorrow. 5, 0 is the focus, and 0, 0 is the vertex. 5, 0, focus. That should tell you that the p-value is 5. You should also know this curls around the focus to the right. It is going to be y squared. Since it's y minus 0, I'm just going to put y squared. 4 times p times x minus 0. I guess I could have just put x. This would be y squared equals 4 times p times x. P is 5, so you just put the 5 in and call it 20x. Good enough. Answer there. Y squared equals 20x. Number 10. A quick sketch. All we're doing is writing the equations for 9, 10, 11. All right, we've got 2, 3. Sorry, 2, negative 3. Vertex. Focus, 2, negative 5. 2, negative 5, right here. Focus. So you do know it goes this way, I hope, which means the p-value is negative 2. It dropped 2 from negative 3 to negative 5. Okay, so once I know that, I just plug it into the x squared one. X minus, remember this is 2, negative 3, so x minus 2 squared. 4 times p. 4 times p, p is negative 2. Okay, then you what? Then you say y minus negative 3, which would make positive 3. Final answer, x minus 2 squared. There it is. Number 8 is done. Number 9. No. Sorry. That's number 10. That was 10. This is 11. 11 says vertex 0, 1. 0, 1. Opens to the right. Goes through the point 1, 2. If it opens to the right and goes through 1, 2, oh, that's, then, I mean, just because it's symmetrical, I know it goes through 1, 0. Right? Okay, I have a problem. And my problem is, how do I find the focus, or the p-value? I can't even see the focus. So you need to think. This is y, because it goes right, minus the y value squared equals 4 times p. Don't know p because I can't find the focus. X minus what? 0. Okay. So, to get p, there's only one way to get p, and that is to solve for p. But to get p, you need an x and a y. Well, here's your x. Drop it here. Here's your y. Once they give you points on a parabola, just put them in and solve for p. You get, let's see here, 2, take away 1 squared, 1, 4p times, put in the 1, 1 minus 0, 1, 1 times 4. 4p, p is what? P is 1/4. Aha. So that would mean I go how far? About that far. There's the focus. P is 1/4. But you still got to write the equation. So the equation comes right here. And it says y minus 1 squared equals 4 times 1/4 times x minus 0, which is just x. So the final answer is y minus 1 squared equals 1x. Number 11. Mark it off. It's done. Number 12. Okay, 12. 12 is kind of nice. They give it to you in the correct form that you want to see it in. This allows you to read the vertex right out of it. So the vertex is, as you can see, it will be take and shift the 0, 0 vertex left, right 2, left 3. There's your vertex. And right now is when I would start my sketch. Yes, you do have to sketch this, right? No, they don't tell you to sketch. I do just because I like to sketch. There it is. It is 2 comma negative 3. Okay. Now, from here, I need to know the focus. Well, the focus is found by knowing the p-value. The p-value, you got to remember, where did the 8 come from? 4 times p. Well, set it equal to 8, solve it, p is 2. Well, where are you going? You got to know if you're going right, left, up, down. Well, this right here gives it away. You're going right or left. P is positive. You're going right. I'm going to go right 2. I'm already at 2, 3, 4. I'm going to go this far. Call that my focus. So there's my focus at 4 comma negative 3. 4 comma negative 3 is the focus. Next, directrix. The directrix is just, instead of going forward 2, use your p-value, go backwards 2. It's right here. It's a vertical line. Vertical line, up, down. So that would be directrix. I call that x equals 0. Next, I want the focus, directrix, axis of symmetry. Axis of symmetry will be the line that cuts your parabola in half. It's this blue line going this way. That would be, since we're down 1, 2, 3, your axis of symmetry, AOS, is y equals negative 3. All right. What else? Oh, endpoints of the lattice spectrum or focal width. You got to remember the focus. At the focus, we have a certain width. How wide is the parabola? Well, wherever this parabola falls, I don't know where it falls. I mean, it could fall here, here. I don't know. But the one thing I do know, I should know that this thing is 4 to the right because the focus is 4 to the right. So this is 4 something. 4 something here too. All right, well, how do we get it? We plug it into our formula way over here. Okay, so we will get, here we go, y plus 3 squared equals 8 times 4 minus 2, which is 2 times 8 is 16. Square root of both sides, you get plus or minus 4. y plus 3, negative 3 plus or minus 4. I'm getting 1 and negative 7. So, oh boy, I got a mess here. There you go. There you go. You don't have to sketch it. I just do it just to see it. I like to see it before I call it good. Number 12. 13. Go to 13. 13. The problem with 13 is it's not in standard form, so I can't really take out the vertex. So I got to do a little magic. My magic will be complete. The square. All right, here we go. I'm going to take half of 8, square it, I get 416. So I add 16 to this side, and I add 16 to this side, and get 4y plus 8 equals, this can be factored into this, can be factored into x plus 4. Over here, on the right side, let's get it to be just y. So factor out the 4 and get y plus 2. I would say the vertex is what? Negative 4, negative 2. The focus. Now the focus is going to be find the p-value. This is where p came from. 4 times p equals 4, so you should know p is 1. What else should you know? This thing goes up because the p-value is 1, and it is x squared. So it does go up, and it's 1, 2, 3, 4, 1, 2. It's right here. And since we're going up 1, this is the focus. This is the vertex. So the focus is up 1. Up 1, you can just pretty much add 1 to the y. You're going to get negative 1. The directrix, well, let's just drop it 1, and it's a line this way, right? That would be y equals negative 3. Okay, and the axis of symmetry is the line that cuts right through the focus and the vertex. That would be x equals, it would be negative 4. Just take a look. It goes right through negative 4. Okay. All right. What's left? Oh, the old endpoints. The endpoints are basically the focal width. Where does this thing actually hit? That's the question. This point and this point. And what you should know is that these endpoints are going to have the same y value as your focus. So your focus has a y value of negative 1. So this would also have a negative 1. So you need to plug this in right here. Okay, and I'm not seeing it very well, so I'm going to go like this and this and come back up. All right, here we go. X plus 4 squared equals 4 times negative 1 plus 2, which is x plus 4 squared. 1 times 4 is 4. Square root of both sides. You get x plus 4 equals plus or minus 2. X equals negative 4 plus 2 and minus 2. So we should know these points are negative 6. And negative 2. I think. Yes, we got it. I got it. That's it. Endpoints of your parabola right there. There they go. And there it goes. Okay. Next up, we're on the back page. We're cruising. Here we go. A searchlight is shaped like a paraboloid of revolution. If the light source is located 2 feet from the base along the axis of symmetry and the depth of the searchlight is 4 feet. What should the width be for the opening? I don't care how you position this thing. You can go like this. Put your X and Y axis here. You could do this. So I saw some of you do this, and that's fine. I don't care what you do. It's up to you. 0, 0 is the vertex. The light source is 2 feet away. This is the focus. Okay, one thing we do know is this thing is how deep? 4. So if it's 4 deep, this ordered pair will be something 4. This ordered pair is also something 4. And that is what, no, what is the width of the opening? They want this distance from here to here. Okay, we're looking for that. But with the p-value of, I think you can see it, p is 2, we should know this equation is x squared equals 4 times 2 times y. There it is. You want the x value. Put 4 in for y. X squared equals 32. Square root of 32 is your x value. So how far over is this? Square root of 32, right? Well, if this is the square root of 32, and this is the square root of 32, negative, then the total distance from here to here would be 2 times the square root of 32, which is about 11.33, no, just 3 feet. Good enough. Let's go on. Hopefully you got that. Next is the bridge. The cables of a suspension bridge are in the shape of a parabola. The towers supporting the cable are 400 feet apart and 100 feet high. Okay, so here's me thinking towers, cable coming down, and I know it's 10 feet above the road. I've already read this problem. The road is here. That's the road. Now, if I put the origin right here at 0, 0, I would know this is 0, 10, because it's 10 feet off the road. I didn't read that. If the lowest point of the cable is 10 feet above the road, find the vertical height of the cable at 50 feet from the center of the bridge. Well, if the distance from the tower to the tower is 400, I would know that from here to here is 200. So this is 200 comma 100. So I already know a point on my problem. I already know this point, it's negative 200, 100. Okay. So I should know the, looking at this, I see that the parabola goes up. I should know it's going to be x minus something squared. Well, the 0 is in the x, is on the vertex, right? And then 4p times y minus 10. Problem is, I cannot go from the vertex. I can't see the focus. So I have to go find the focus. Well, I got to go find, sorry, I don't have to find the focus. I have to find the p value. To get p, you will need x and y. Where's x, y? Here's x. Here's y. Drop them in. Right? Drop that in there. Drop the 200 in here. And solve for p. Now, I'm sorry, I forgot to read this to you, but the question says when you move over 50 feet, how high are the suspension cables? Well, this is 10 right here, so you know it's just a little higher than 10. Not much, but some. Okay, so let's go find the equation. So in for x is 200, take away 0. P, we don't know P. This would be 100, take away 10. This would be 90 times 4, 360p, equals 200 times 200 is 1, 2, 3, 4 zeros, 40,000. Divide by 360. Cross out the zeros. I would reduce it by 4 and get 9. I'm getting 9. No, divide by 4. Get 9, divide by 4. You'd get 1,000, I believe. Yep, you can get 1,000. There's P. P is 1,000 knights. Let's move over, write the equation. Here it comes. X squared equals what? 4 times 1,000 knights times y minus 10. You end up with 4,000 knights times y minus 10. Okay. Now, that's the equation that fits the parabola. But on the parabola, you want to know, what do you want to know? You want to know right here, at 50, how high are the cables? Question mark. That's what you want to know. So let's go plug 50 into the equation for x. When you do that, you get 50 squared. Solve for y. Remember, you multiply 50 squared by the reciprocal 9 4,000ths to knock out this. You would now add 10 to get your y value. So whatever this is, plus 10, and I have on my paper, it is 15.65 feet. There you go. 15.65 feet. I go back up here. I look. I go, hey, does this look like it'd be about 15 feet up? This is 10. Yeah, it looks like it's reasonable. I think it's right. I know it's right, but I'm just trying to tell you, you should think about your answers, okay? All right, 15's done. Now 16. Okay, we're doing ellipses. I'm going to shut this down and start a new video in case you want to just look at that video instead.